Well, we kind of wanted to do the same thing in networks, because wouldn't it be good if we could take the service, the content, and pre-distribute it closer to consumers who wanted it? And then when we say it's here, it's everywhere. And do we need to even wait and pre-provision? Can we use the secret of things like the DNS itself, where the first answer gets copied by the DNS infrastructure in computers close to who's asking, close to, but not the same. So all your other customers in that network who ask for the same domain name shortly after the first simply get a copy of what the first answer was. What's the IP address of google.com? Oh, that's boring. I've already done that, 20 times today. Have a cached copy. Ding.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking again to Geoff Huston from APNIC Labs in his regular monthly spot on Ping. In several recent episodes, Geoff has asserted the routing function in the internet has moved from IP-level packet forwarding models into a process driven in the name-to-address lookup function. Who you are and where you might want to go is no longer just about your IP address and what you might think is the other end across a network. It's now about where you are and where intermediary services can best service your request from. But how does this really work in practice? What kinds of processes determine where you should be served from and who decides? IP-level routing hasn't gone away. There's still a very important routing method called anycast for selecting the closest server to be used, and this is deployed at scale. But it's increasingly being augmented by name-based, DNS-based methods to determine where to go. Geoff, welcome back to Ping.
Hi, George. How are you today?
I'm good, Geoff, but I'm confused because you have spent so many of your recent Ping recordings talking about how names are replacing routing as the steering artifact for the global internet. And I keep meaning to ask, how does this work?
Right. So let's get into that a bit, because I actually think this topic is totally fascinating. And I actually think it's revolutionary in the change that it's making to the concept of computer networks. Computer networks were, I suppose, a lot like telephone networks. I'm here, you're there, and the job of the telephone network is to actually carry my voice to you and carry your voice to me.
Yep.
I can't teleport you. I can't change you. I can't duplicate you. The network is there to bridge the two of us together without either of us getting out of our chairs. Great. Now, when we built computer networks, the first thing we did is build it in the image of the thing we knew. Didn't have any other model.
Yeah.
So we kind of built them as a way of having conversations between computers. It's over there. Mine is over here. I tap on my keyboard. Little packets get scurrying over to your computer. You tap on your keyboard. Little packets go scurrying back.
It's kind of inherently me to you, you to me. It's not typically a form of communication that's inviting the idea of me to 16 other people or me to 2 people at once. It's building it point to point, you to me to you.
Right. And oddly enough, there were these other models, and we have their paradigms to some extent. Radio and television is a form of broadcast where everyone within a certain radius can listen to a single point source. And the source is available to anyone within that served geography. And multicast is slightly more selective. It says, I wish to simultaneously get a bunch of people to listen, and I'd actually like to agree that they're listeners. But, we have computer analogies, computer networking analogies of those other models as well. Although fascinatingly, they were really hard and they never took off in the mass market.
Yeah.
Part of the problem with multicast is that it was, to be perfectly frank, a really fragile technology. And the only folk who tried to use it were actually folk who wanted to have a digital version of radio broadcast. And the idea that the audience would all line up at the same time to listen to you seemed a bit far-fetched in today's world. They don't do it like that. And so it never really caught on.
Well, I've just watched the launch of Artemis 2 on the start of its journey, mankind reclaiming outer space, one rocket at a time. And because of the nature of an event that is happening at a set time, there are still things, sporting functions, opening of Parliament, royal marriages, where people want to line up at the gate. But if you're talking about the vast majority of digital content that we used to see as a collective engagement, it's no longer available at 9 p.m. and only at 9 p.m. It's you watch it when you want it. So that model of let's get everyone together in time and say go, it kind of narrowed down.
It's gone.
It's gone.
I didn't see the launch. I'll catch it up later on streaming.
Ha!
Me and billions of others, no doubt. So yes, that paradigm of simultaneous audience, I think, doesn't exist anymore. I think the problem was insofar as the original version of computer networking was actually small transactions. They weren't large ones. It was more about replacing the office fax with electronic mail. It was web pages that were realistically short, sweet and simple.
Yeah.
Images rather than movies.
If we can make the event of getting it really quick, you can get on with reading it at the speed of human eyeballs. And me, the network, I don't have to sit there. I can deal with someone else's problems.
Right. So the task of the network was simply to carry the consumer, the user, the client, to the server where whatever it is they wanted was, and carry the answers back. And by and large, this served us for a couple of decades. But as our computing technology got better, our displays got better, and we were digitizing almost everything. What actually happened, of course, was that computing was getting more interesting. You could do bigger things.
When I transited from Britain to Australia, this was around the time that Ken Thompson, one of the two people who built the Unix operating system we all live and depend on nowadays, he was one of the privileged people who had a server at home with a 600 megabyte disk drive that he had dedicated to recordings of music because he was exploring psychoacoustic effects under compression of audio. And I remember having conversations with people saying, you couldn't afford to send music like that down a network. If you had a modem, it would take a month to get even an hour's worth of music out of it. But the thing is, he was researching something that, as you've just said, has come into the fore as computers have got faster and as networks have got faster. We can now do things that we simply couldn't imagine when this form of networking was being invented.
So yes, computers have got faster and cheaper. Storage has got cheaper. 600 megabytes, I'm sorry. A significant problem today is 600 petabytes. A major problem is 60 terabytes. But under that, go down to the store and buy a bit more either spinning Rust or your solid state storage and you're done. So in some ways, we're living in a world of abundance. But one thing hasn't changed. And oddly enough, that's the speed of light over distance. And when you think about computer protocol performance, distance is a pain because the way we actually make networks work is a feedback loop. Oh, go a bit faster. There's room in the network, says your feedback. And it's this delay between desire and reality. If you stretch it out, it's like living in a world where everything happens a second later. You have to slow yourself down.
Yeah.
Because you do something, you have to wait for a response. And the issue was that although we had heaps of bandwidth, heaps of computing, heaps of storage, we still had this problem that distance was killing us.
Right, because the effect of the speed of light means that the feedback loop, you to me, to either tell me speed up or slow down, that message necessarily has the delay of the speed of light between you and me. The further apart we are, the more delay there is between you saying stop and me actually stopping, which means my responsiveness to changes in the network, whether it's full or empty, congested or noisy, is necessarily bound in that delay.
So it's really hard, oddly enough, even though we have high-speed networks, very high-speed networks, it's really hard for a user, a client, to actually exercise that. So if I want to stream a video from, I don't know, I live in Australia, so stream a video from the United Kingdom, from France or Germany, from the other side of the world, even though every individual component might be megabits of capacity, and there might be available megabits of capacity, I mightn't get it. And this was kind of the issue that was confronting originally folk like Microsoft and Apple. Their problem was that they released operating system updates, every couple of months and said, right, there's a new update for Windows available. Come to Seattle with your network and pull it down from our servers. Now, nothing wrong with that other than a few 100 million people wanting to do so simultaneously.
Yeah. Oh my gosh, the Windows release is midnight in America. I'm going to wait till 1 minute past midnight and fetch it.
You and 100 million of your best mates. And so things melted. And it didn't take us long to figure out, well, if computing and storage is so cheap, let's replicate the content in advance. It's like in the old days, a book publisher would send in advance copies of Harry Potter and whatever it was to bookstores and then announce the opening day, and the stores had already been pre-provisioned with the book.
Yes, there were a few lawsuits where the stores were selling pre-release copies of the book under the counter to journalists, and people were breaching the magic wall of
the secret covenant or whatever it was. Well, we kind of wanted to do the same thing in networks, because wouldn't it be good if we could take the service, the content, and pre-distribute it closer to consumers who wanted it, and then when we say it's here, it's everywhere. And do we need to even wait and pre-provision? Can we use the secret of things like the DNS itself, where the first answer gets copied by the DNS infrastructure in computers close to who's asking? Close to, but not the same. So all your other customers in that network who ask for the same domain name shortly after the first simply get a copy of what the first answer was. What's the IP address of google.com? Oh, that's boring. I've already done that, 20 times today. Have a cached copy.
Cache, the magic word emerges. Caching.
Well, I'm actually thinking it's distribution. Caching is what we call it in the DNS, but in the server world, we call it content distribution. That what you're trying to do is to take a big thing, be it a video or any other kind of large volume server or servers content, and as you stream it outwards, you keep a copy close to, but not right inside the end user's environment, in their ISP, for example. So now when anyone else asks for the same video, and I bet you they will, I'll be able to serve it remotely and not touch the network. Brilliant. All of a sudden, I've got rid of the network. It's gone.
Well, you needed a pipe. You could push the stuff down to get it to all those places you're choosing to put it. So a network has to exist for you to push stuff to the places you want to cache copies of it. But a network isn't the same as the network, is it?
Well, let me make your brain explode then, because let's Geoff's content distribution system rig up a bunch of virtual servers on borrowed hardware or leased hardware in a few thousand places all around the world, close to populations. And they will serve Geoff's content locally over the internet protocol. Fine. How do I feed those front ends? Well, I have the Geoff content factory somewhere else, doesn't really matter where, and I want to feed it in advance. Ooh, that means I could trickle feed it. I don't need to be fast. It's not on demand. I'm pre-provisioning. What protocol should I use to do that pre-provisioning? Apple Talk, DECnet, SNA. Doesn't matter.
Private.
You don't see it.
It's private.
It's all private. It's private. And whatever protocol I choose to use is kind of my business between my master server and my front end, retail points of presence, my content points of presence. So in some ways, all I'm trying to do is deliver this same content all over the world through the last hop. but how I do so internally is kind of my problem and no one else's. And so it kind of doesn't matter. And so if Google internally uses BBR or IBM SNA, no one cares. It's not our problem. It's their problem.
Yeah, from talking with the engineers who manage the FreeBSD distribution framework, I think they are existing in the margins where they have to try and reduce cost here. And they've constructed almost, I believe, a two-tier model. They have regional nodes that they push to, which means the center only has to arrange for maybe 5 copies to be pushed out. And then local nodes do a pre-provisioning fetch from a regional node. So they've kind of invented 2 levels of behavior and they've got less complexity. But in the end, nobody in the real world has to care because all they see is fetch FreeBSD from a local mirror.
You could be talking about Akamai or Fastly or Google or any of the others. They all use the same techniques. It's really common and it works. That's the good thing. It works. So, okay, distribution is kind of a solved problem. But let's go to the other side of this. You want to go to Geoff's favorite videos served from Geoff's content distribution network, and I have 1,000 points of presence. Now, if you make a dud choice and pick a server that is not near you, but on the other side of the world, no one's better off, are they?
No.
You're going to have a bad experience because that was a bad choice.
I feel like this has been the longest preamble in the history of podcasting, Geoff, because we've just arrived at the entry point. How? How does it work?
Well, I was wanting to kind of motivate it and get,
you got there.
I suppose, everyone to understand the nature of the problem and kind of why it's not straightforward. And there are a number of techniques, if you will, to actually answer this. And the first approach, which oddly enough was very controversial, was actually to put the same computer platform everywhere that you're serving. So this computer platform uses address 192.168.0.1. And I put another one in Paris, 192.168.0.1. And I put another one in New York, one in Sydney, one in Singapore, one in Beijing. I use the same address everywhere. And I go to the routing system and go, hi, I'm over here and here and here and here.
Now, you've been at some pains when we talk BGP and the behavior of BGP, selection of a prefix to route to. You've talked about how if you announce a big address and then announce a more specific wins, that becomes the thing you look at. And separately, you've talked about the loop detection mechanism becoming a cost measure that lets you determine which is the lowest cost path to take. And I'm looking at this situation where you're announcing exactly the same address in BGP in lots of places, and I'm asking myself, what mechanism makes me pick one near me and you pick one near you and some Parisian pick one in Paris?
Well, you said it yourself. BGP picks the route with the smallest metric. Now, in BGP, the metric is the number of networks I need to traverse to get to where it's being announced. So if this conversation is you and I sitting in, say, America, and the server is being announced in, say, Paris, it is likely there might be a local network, a transatlantic transit network, and another local network. It's likely the cost to get to the Parisian server is 3.
Right.
But I've also got my server in America. It may well be that it's very, very close to you, an adjacent network. Cost 1.
Right.
BGP picks the lowest cost. And so if you go to 192.168.0.1 and you're in America, you will go to the server that the routing system, BGP, thinks is closest to you.
So in a sense, it's almost like a decision-free outcome. I don't have to pick where to go. Routing optimizes the decision facing me and the guy next door, and simultaneously some Parisian guy sitting in a flat. We all get optimized in routing to the closest point.
Right. And you go, geez, that sounds weird. And let me point out a few major users of this anycast approach, where you put the same address everywhere and I point to the root of the DNS. The root of the DNS is served by 13 unique v4 addresses and 13 unique v6 addresses.
Right.
Each notional server has a v4 address and a v6 address. So there are 13 root servers. There are 13 machines that serve the root. No, there are 1,500 of them. Well, how does that work? Well, each root server actually has a large number of servers all over the world, all over the internet, all listening on the same IP address, the same. So there are 13 separate little, what we call anycast clouds in v4, another 13 in v6, and the routing system automatically takes you to the closest server. No one does anything. BGP looks after all of this. And it's actually not a bad approach. You've kind of outsourced your problem to BGP. Knock yourself out, kiddies, So not only does it keep the root of the DNS evenly loaded across the world and stops the root servers from melting through overuse or any individual server, the technique also works for efficiency. You just get taken to the closest one. Who uses that technique? Cloudflare. So Cloudflare have a very small number of IP addresses, but if you look hard at their network, you actually find the same IP address pops up everywhere because they're anycasting and therefore direct you to the closest content on Cloudflare's network is certainly left to BGP. Easy.
So nothing comes for free, Geoff, and I'm going to imagine there are potential pitfalls in this. I mean, I'm sitting here thinking if one of these boxes breaks and I need to log into it, I can't use this magic anycast address to log in. There's got to be at least another address on it that is unique to each box.
Oh, you need a service address that's unique, but let me tell you what the problem is. The network, in topology sense, is not long and stringy. It's short and fat. The average AS length on the internet is a little over 4 networks, 4. So the average AS metric is 4, which is really coarse. And if you attach to a big spanning network, so if Geoff's ISP spans all of America and Europe with one AS,
right,
then in terms of BGP metrics, every location in Europe and America is the same distance. How do you know what's closest?
Right.
And the answer is BGP doesn't. And so that will give you poor outcomes if you are dealing with networks that span large distances. And guess what? There are networks that span large distances. And that way, Anycast kind of makes, unfortunately, suboptimal decisions. And we see this.
Right. You could wind up being in America with a resource in France looking equal cost to a resource quite close to you logistically on the continent, and you could incur that time delay of a sub-oceanic fiber optic link because BGP can't tell you should look somewhere else.
Right. And the right research folk, one of their early experiments with Atlas and mapping was to actually ask their Atlas nodes, which instance of arootservers.net do you go to when you ask the root of the DNS? Which instance of B? And so they were trying to actually isolate how well does this root server anycast system actually work? And obviously, when you go looking for anomalies, you find the world is full of them. And of course, there were Atlas nodes in Europe who thought via BGP that the closest anycast instance of one of these servers was in places over the other side of the Atlantic in America and so on. And it wasn't rare, it's common because BGP is pretty coarse. Short, fat networks don't really do a good job with anycast. Okay.
And if I front up on a big network and say, hey, could you make your network a bit more granular? Could you grind it up a bit to divide it into the chunks that would make my life easier? The inevitable point is, yeah, I could do that.
But you've got to pay me. You've got to pay me large amounts of money. And the real answer is, I don't think you're going to, because I'm not hosting your content and I'm not hosting your customers. I'm just the transit dude in the middle. And so the economics don't really make this any better. And trying to make a longer, thinner network out of a short, fat network is kind of anti-gravity. No one wants it. So it's not going to get any better. oddly enough, it's going to get worse as we move on. So in some ways, anycast has its limits. And if you really want to start shaving things down, if you really think there should be a difference between Frankfurt and Paris, if there should be a difference between Paris and Lyon, there should be a difference between Paris and what's a town very, very close to Paris? Orléans? A few kilometers away. If you really want to make that difference, or a distinction between Tokyo and Osaka, BGP isn't going to do it. It's not.
Right. So BGP was almost the decision-free mechanism where you, the content provider, and me, the client, had nothing we had to do to find what was considered the air quotes best choice. And what we're kind of getting to is, well, you actually are going to have to make a decision now. And there's that magic moment. Who's making the decision? How do they do it?
So if I can't use anycast and get a free ride with routing, let's try a different approach. So again, I have my content distribution network, and I give each of these points of presence a different IP address. 192.168.1.2.3.4.5. So let's have 1,000 of them. You ask for jeffscontent.com. Now I've got to go, I could give you in the DNS 1,000 different answers. Which one is the answer that's good for you? And you put your little hand up going, well, I didn't really want all 1,000 answers. I can't cope with that. Not my problem. But don't give me the one that's furthest away. Please, just don't do that. Anchorage, Alaska is only good if you're living in Anchorage, Alaska.
So I trigger a decision having to be made because I say, I want to get somewhere. And you, because I'm getting somewhere by asking about, tell me the address of a name, your systems or someone on your behalf is getting that call that's saying, George, I want to do this. And the problem is, how can I know, based on you asking, where the best place for you is? What do I know to help decide?
So let's make a sweeping assumption. And it's probably not that bad, a sweeping assumption. You and your DNS agent, your recursive resolver, the thing that actually asks your questions for you, is normally provided by your ISP. Let's assume that that's close to you. So now I have a third party, your resolver, and I have it asking me, the authoritative server for my content distribution network, a question about content that I'm serving. So now I've got a simple problem, or simpler. An IP address is asking me about a server. I have 1,000 possible IP address answers for that name. I just need to pick the one that's closest. Okay, we have geolocation databases. In its crudest sense, I can map to countries. Let's put a country code on your resolver that asks the question. Fair enough. You live in Japan. Let's shuffle through my list, find an answer where the server is located in Japan. That's the answer. So now you're getting steered to something that I think is good.
It definitely sounds like an improvement against large flat networks that potentially span interoceanic networks and different economies. But I'm not feeling like you've kind of got perfection yet, Geoff, because some economies are very long and thin. Chile is a massive, long, thin stripe down the side of South America. And if you happen to be right down the bottom of Ushuaia, you are not close to Santiago, right up in the north. Japan is a very long, thin island. It's quite a lot bigger than people think because of the Mercator projection. And if you're right up the north, you are not close to right down the south. So you fix the problem by keeping it within Japan. I'm giving you a thumbs up. It still hasn't got close to me.
Well, before you start throwing rocks, let me observe that this is the model used by Akamai, one of the major content players on the planet. They do this by DNS. It's not even a clever trick. It's an obvious thing. When you serve content through Akamai, when you say, take this content and serve it at Akamai, they say to you, look, instead of serving or giving an IP address of your server in the DNS, CNAME it, alias it to us. And so they say, if I want to serve example.com, they might say, in your DNS master zone, use the CNAME for this service, www.example.com, and CNAME it to www.example.com.edgekey.net. Who owns edgekey.net? Akamai. Ooh. Now I've got www.example.com.edgekey.net. Where does that map to? Another CNAME. Now, the trick is that second mapping depends on who's asking, because I maybe have 4,000 possible answers that identify an edge location by name.
Right.
And I do a magic thing that says www.example.com.edgekey.net, CNAMEs to the server in Tokyo.akamaiedge.net. What's its IP address? Well, that's constant. That's easy. The server in Tokyo.akamaiedge.net, is 23.195.84.241 or whatever.
Right.
And so now, with just a little bit of mucking around with CNAMEs, I've got a decent way of doing this. As long as I can triangulate and say, A, you live close to your DNS resolver. So if I optimize my answer against who's asking, I can steer you to one of the servers that serve the content you're after that's closest to you.
So having kind of kibitzed and said, yeah, I don't like this, don't think it's perfect, I want to back off and observe. I'm sure I'm using Akamai services all the time.
Oh, you are.
And proof by example, I'm not seeing massive amounts of, this kind of suck. So as a consumer of services, I think we might be in 80-20 land, Geoff. This works mostly if I'm not doing stupid tricks with my DNS and if I'm mostly using a DNS server close logistically to where I live and work. It basically seems to work.
Many folk might bank with the Bank of Akamai. They might. It works. And the beauty of this is also that you can't see those translation names. When your browser then connects to this IP address of an Akamai server close to you, you say, hi, server, I want to connect to www.mybank, and I want to create a TLS connection. And the Akamai server goes, not a problem. I am configured to be an alias for that banking name. Here is a key. Here is a key exchange. Here is a TLS connection. Let's do this. So the entire thing is seamless to the user. And I've now managed to, by doing a simple sort of trick with the DNS, steer you to something that is really close to you. Presto. It's fast. It's cheap. Did I mention it's fast? It's really fast.
Yeah.
Because it's local. So it kind of works. Yes? So now, George, let's start throwing rocks.
Yeah. So I want to watch content from the BBC, and the BBC says, sorry, chum, your DNS is in Australia. So I ring up a mate with a DNS server in the UK and I let me ask questions through him, and the BBC go, not a problem, buddy. I see your questions coming from the UK. Here is Doctor Who. It feels like I can drive through geofenced IPR rules if I can make my questions come from the UK.
More than 10 years ago with Netflix, if you changed by simply going into the config part of your computer and changed who your DNS resolver was to your country of choice, Netflix would open up the library of that country because it assumed you were your DNS.
Yeah.
And yes, it was and probably still is abusable from that respect.
Yeah.
And the other problem that's just as bad are these open DNS resolvers.
Yeah.
Like 1.1.1.1, 8.8.8.8. Well, the thing is, which actual DNS engine did your query go to? You don't know. But when Akamai get the query coming from one of these open DNS resolvers, say Google, it's not clear that the address being used by that open DNS resolver when it asks Akamai is close to you. Oh, you're coming from Paris. Oh, you're coming from Moscow. Oh, you're coming from Madrid. It's really, really hard to nail it down.
Yeah.
And so under some pressure, Akamai and a few other content folk convinced the big content distribution networks to add a security leak, a nightmare. When you ask the authoritative server, why don't you attach the client address? Well, can't do that. Don't want to do that. Why don't you attach the client's subnet? Oh, that's okay. That's not very privacy leaking. Rubbish. We'll use that. So we actually intrude into the DNS between the recursive and the authoritative. an item of data that actually points to the original user.
Right. So the person asking the question is the primary vehicle that can at least target, in a lot of cases, down to an economy, but we've changed the protocol to intrude a flag going out asking the question, this geezer in this suburb in Ginza is asking about this TV show. And the belief I have is, oh, well, you just identified me to Ginza. There's a million neighbours. And the belief you have is nobody's lying here. He really wants the server in Tokyo, not the server in Hiroshima, because he said Ginza. So it kind of sounds better, Geoff.
It kind of sounds better because, in essence, you're giving a few more clues of information. Okay. How good is a subnet as a privacy protection? Nah, not very good. You're leaking information about you that maybe you didn't want. The plus side of this, who controls the mapping from name to number? You see, in BGP Anycast, the service provider had absolutely no control.
Right.
BGP. But here, my DNS servers control that mapping. I can twiddle and play. If the server in Osaka is flat on its back, howling at the moon, and the only available capacity is somewhere else, Tokyo, whatever, I can actually intrude into this. And with a short life answer, I can tell you somewhere else.
Short life, that would be because these kinds of answers wind up having a cache behavior. And if I've cached in your system, you have to go over here. For the lifetime of the timer, I'm going over there.
The thing that makes the DNS work so well, caching, kind of is your enemy if you're trying to do some degree of dynamic load balancing or optimization.
Right.
Because once you give an answer in the DNS to that resolver, everyone else who queries for that name is going to get the same cached answer.
Right.
And if you want to recompute, then the thing is give it a short lifetime in the cache, because otherwise the first answer is sticky for an unknown number of subsequent people. And so to do this, you lose caching.
So these are two different kinds of rocks being thrown here. One is it's a bit of an anti-pattern for efficiency in the system.
Yep.
Okay, we're going to have to deal with that. And the other is it's a big privacy concern. You don't really get to keep your privacy when you ask these questions anymore.
Yeah, tough. So what do you do? Well, we've just discussed, I think, almost the transition of networking and technology. We originally started with a smart network and dumb devices. It was called telephony. And we started to put more and more, smarts in the edge devices and strip out the middle. So using BGP kind of relies on magic in BGP. Devices need to do very, very little. Using the DNS lifts it up one level. So now you've got the DNS doing this distance mapping and trying to get you to the optimal point. Why stop there? You could do what Netflix do. There is an Amazon server or 20 or 1,000 where all the initial transactions for Netflix content get passed to on the west coast of America. Oops. But that's okay, because then there's an application problem, because you divide your content into manageable chunks, little bits, and you have the ability to go, well, user, you're making contact with me and you want this content. Now, it's not a DNS question. It's not even an IP routing question now. It is a content streaming question in the application level.
And it's between me, the user, who is paying you, Netflix, for this service. I'm giving you money. And so this anonymity and privacy thing, well, I was never going to have any privacy in you because I was always going to pay you to give me the things that I tell you I want to get.
And you want me to know it's you because you're paid me and you want that service. So,
I do.
This is now consensual disclosure.
So there's a third thing kind of buried underneath here, which isn't really material for the technique we're talking about, but I think it's part of the story. You also, when you send me things in Netflix, you send it fast enough that I can build up quite a big buffer in time. I get content from you that spans probably 2 or 3 minutes in me, so that even if you have to stutter a bit sending stuff to me, I don't see that. watching this movie. And so that chunking technique where you're saying, oh, that server's dying, I need to move you somewhere else. In your clients, most of them have a bit of a buffer here, where if they have to flick open a link somewhere else and start dealing with it, it isn't actually going to affect their streaming.
Everything is a compromise, isn't it? You can do, and for a long time we did do, high watermark, low watermark, trying to get the playback buffer in the device that, the customer is using, the television, if you will, trying to keep that buffer full. And when it got to a low watermark, you just slammed data down the line and then went quiescent until the playback got to the low watermark threshold. We call that the Netflix spike. And it's a bit like hitting the network with a sledgehammer once every few minutes. And it's just as painful. Modern thinking says, don't stress the network like that. Bad things happen. You just drive the network into bad places. Try and even your load.
Right.
Try not to do stress techniques, but do the gentle feed. Yes, it makes it a little bit more difficult to change where your stuff is being served from when you need to. But at the same time, the network's going to behave a whole lot better. The good news about this approach, because now it's at the application level, and I have control over who is delivering you elements of the service, is I can start playing with what-if questions.
Yeah.
I've been serving you from Osaka for quite some time now. I wonder if Tokyo could deliver you better service. We're up to chunk 1023. Let's deliver 1024 from Tokyo. And tell me, because it's my software at the other end, tell me how that was for you.
Yeah.
And I can then dither and try and get really fine-grained accuracy on what is the best service at this point in time.
And so this mechanistic behavior, it might be using intermediaries, it might be using locally best service, anycast in all kinds of weird ways, but we have moved back into application layer decisions between you, the sender, and me, the recipient. It's an instrumented dialogue.
Right.
You get to understand it without intermediaries having to make inferences. There's ways that you can control the behavior, and I can control the behavior in software.
So as we've moved content up into video, as the content stuff gets bigger, and we're now talking about, hundreds of megabytes or gigabytes, then the whole idea of make a decision once on what's best and stick with it, which is Akamai's decision, doesn't really work very well. And so you have to constantly use some kind of adaptive feedback to check if that original decision could be bettered, if there's another way of doing it that could improve the response, which is where Netflix and YouTube and a number of other streaming platforms have gone to, because it becomes an application issue that can best actually address this problem.
So let me just run history on the quick track. We had it's point to point, and you could even have operators plugging between patch boards to connect you to me.
Yeah.
We had it's packets, and we're going to give them addresses. And suddenly it's about knowing how to get there, which means routing. We had routing can be made to look like one thing is anywhere, and you have to use a routing trick to pick which is the best one.
Yes.
We then say, that isn't good enough. Can we go back to something that's about names? Who am I and what do I want to get? And we start using mechanisms in names. And you've now moved up to, well, it is names, but it's also got a lot of what are you actually doing with me? Let's measure this. Let's optimize this. Kind of sounds like it's name-based. There's a bit of the routing story still in it, but it's also smarter.
Well, it's kind of pushing the problem further and further up into where I think there is intelligence and information to make it. So the DNS problem is I have control of that translation. I can select a server for you, but then we're both stuck in that selection. We can't change it easily. When I start to dither at the application level, I have a huge amount of flexibility, and I can actually figure out, was my original decision good or bad? And if it's bad, are there alternatives that can offer a better service? Don't forget, too, that there's a lot of remedies. I can reduce the quality of the signal to reduce the volume, or, preferably, I can stay at the same playback quality, but move to a server that has a better chance of keeping that quality up for your experience. And so that flexibility sort of plays into hands of the video streamers going, I'm really interested in user experience and the quality of that. I think I could do a better job. What does this mean, I suppose, for interoperability and standards and all that kind of stuff? The answer is no, not really anymore.
No, this has moved out of the domain of let's do it all the same way into I've got special secret sauce.
There's Geoff's secret sauce, there's George's secret sauce, and a playback from Geoff's server might not necessarily work with George's receiver. It's not that kind of interoperability anymore.
Yeah.
Each of these application level, content factories and distribution systems work in their own ecosystem.
Yeah, we're building vertical markets and vertically walled gardens. You want to do this behavior? It's going to be good in me. And my special sauce makes it better in me than from the other chaps. Stay with me.
Right. And it kind of goes, well, but I'm a minnow in this world. I'm just a starter. Oh, God. I'm sorry. You're back to banging the rocks together, dudes.
Yep.
You're doing a web-based playback buffer because you're not big enough to build your own ecosystem.
Yeah.
And it kind of does play into a centrality argument, yes.
Mm.
But on the other hand, it also says you can do a better job, but you need to be able to reach deep inside the applications and the systems that are making this happen and customizing it for your needs.
Yeah.
And that's sort of where we stand in this, that, it's a game for a small number of high-tuned approaches to this problem, delivering experiences, I think, that are amazing, but limited to a few large players to actually optimize that.
Yeah. So we've kind of got where we needed to be, name-based service delivery, efficient and local, but along the way, we also bumped into some realities in the modern world. Nothing is free, and this behavior has emerged in a way that's tended to concentrate market power a bit. On the other hand, as consumers, we're making decisions all the time in this environment, Geoff. Maybe this is something that we have to be prepared to do eyes wide open.
As consumers, we make choices, yes, and this is all driven by those choices. I want better quality video. I want quality that's better than what I can even get from local broadcast, and so on and so forth. And that's what drives this. And I suppose the observation these days is if you look at the proportion of traffic volume and even the proportion of consumer money, we are a video streaming network streaming down the last mile. That's what the money says. Everything else is a marginal behavior with a few percentage points of revenue on the side.
Yeah.
And of course, the big volumes drive the industry as a whole. This is what we invest in. So very capable, very fast last mile networks, 5G, 6G, fiber, you name it. That's what customers want. And a densely driven local data center network where the content is replicated densely at a level of cities, not ISPs, not countries, at a level of cities, of population dense points. That's what we're building at the moment. And you go, well, how does this work out in the future? I don't know. AI data centers are so big and expensive. We're back to a couple per country, if you're lucky, the power systems and so on.
Yeah.
I suppose the real answer is we really don't know what we're building.
No.
But we're spending a lot of money building it anyway.
Yeah.
And that, I think, is another topic. The AI, is this a boom and about to go bust, or is there something behind it? But we can talk about that.
That's a story for another day, Geoff.
Another day, George.
But this has been absolutely fascinating. Thanks, Geoff.
Thanks, George. Thanks.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also, remember the measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time.